Hello and welcome to section 3, in which we will be building architectural marvels using Python. First, we will be laying the foundation using duck typing and object-oriented classes. Then we will look into architectural design, which includes OOP inheritance. After that, we will start building our first building with multiple inheritance. And then we will explore the greatness of software. So let's get started. In this first video, we will be laying the foundation. We will be looking into Python's duck typing. We will look into the limits of duck typing. We will advance to inherit from abstract classes. We will enforce implementation of abstract classes in subclasses. We will build some functionality into our abstract classes which make them no longer abstract because they have some functionality built into them. So we're gonna call them base classes from here on, and then we will move more functionality into those base classes. Python does have a special language feature which is called duck typing. That might sound funny, and it is funny, but what it means is Python is a dynamically typed language, so if it walks like a duck, if it talks, quakes like a duck, we consider it a duck. We don't have to cast the type into a specific type. We don't have to ask what instance the type is, so it's called duck typing. And it's kind of cool because what it really means practically is we can build a cathedral here, and we build a cafe. Our cafe is, well, it's a Java house here, and the cathedral is Notre Dame. And as long as those two classes have the same methods, in this case we have two methods, build and visit, both classes have the same methods, they don't take any parameters, so as long as they have the same thing, the same methods with the same signature, we can create the things. And well, we create the things, and in a loop we can just call the methods on them. So we're creating a tuple here, Notre Dame, Java house, those are the two instance variables. And the things, we create the thing, and it works. They are not using inheritance, they are unrelated classes, but they have the same two names as method names. So this is called duck typing. Now the next thing we do is we build a car. We can build cafes, we can build cathedrals, we can also build a car. So we create a method here and a class called car and the method called build, same as the other builds here. And when we run it, we are getting an error saying car object has no attribute visit. Well, we can visit a cathedral, we can visit a cafe, we don't really visit a car. So in this, even though we can build a car, here our abstraction falls apart. It's probably not a good idea to mix those three classes together. With duck typing, we can do that, and there are some workarounds, but anyway, we'll get there next. So instead of using duck typing, what we can do is we can create a base class. In this case, we could call it an abstract class. Abstract because it does have some methods, but the methods we just put in pairs here, they don't do anything, so it's abstract. Abstract means it's just an abstraction. Now cathedral and the Java cafe and our car inherit, all three classes inherit from the class it's called thing to build. And that class, the base class, also called superclass, has two methods. When we run it, we don't get an error anymore because the methods do exist in the base class. Even though car does not have the visit method, this guy here, we don't get an error because it inherits from the base class thing to build, and the base class has this method even though the method doesn't really do anything. But no more error, so that's one way to get around those errors. While it's good to not get any errors, sometimes that's not really what we want. Let's say we have the thing to build and this class is being inherited from the other classes, and we want to make sure that every subclass, every inheriting class actually implements the methods we define in this interface here. So we can enforce that every subclass implements those methods with raising an exception. And the proper exception is not implemented error. We give it a string here, and we are saying all methods, all subclasses have to implement these methods, every single one of them. So now when we run it, we get the same or similar error as before. Our call clause cannot be visited. So, but that's a good thing, because it shows us that our abstraction is basically wrong. We shouldn't mix cars with buildings. Another way to handle these kind of situations is to do a partial implementation in the base class. So here in the thing to build class, base class, we implement visit by saying if it's not being implemented, then we print out this thing cannot be visited, which is appropriate because the car can't really be visited. So like, let's say we say welcome to our cathedral, welcome to our Java cafe, and the car is, we're building the car, but it cannot be visited. So we have a default implementation. It's just a print statement in our case, but it could be something else. It could be really doing something. It could be connected through hardware to really do something. So here we just use print. But this is a default implementation. So in this case, I think our thing to build class is no longer abstract, because we have some implementation here, so it's partially abstract. That's typical of abstract classes. They can have some default implementation. Now, a better way to do it is to not only have a partial implementation in the abstract base class, but also some real things. So we added an init method here to the base class. All inheriting classes like cathedral, cafe, and our car inherit now the init function. And so in the init function of the base class, we are expecting a name, and we default it to unknown. Sometimes if somebody doesn't pass in a name, then we don't know what the name is of the thing we are building. But if they pass in a name, then we can print it out. We can say welcome to Notre Dame de Paris, or welcome to the Java house. And in the case of our car, we can give the car a name, but we're not gonna visit the car, so it still doesn't say anything to be visited. This is more typical. You have, like, in the base class, you have some default attributes that all inheriting classes can make use of. So the cathedral has a name and the cafe has a name. In this video, we laid the foundation for our future designs. First, we looked into duck typing and the limits of it. Duck typing, again, is a special feature of Python. Other programming languages do not have that. Then we, after the limits, we saw how we can inherit from abstract classes and how we can implement some functionality within those classes, making them no longer abstract. So at that point, the abstract base class is no longer abstract, so it's regarded as a base class, or also sometimes named super class.